Hello, I hope you are all well. And today I will discuss about the non-penetrating radar GPR test and method, and also analyzing the how the result or interpreting the image uh, of the ground penetrating radar uh, of the subsurface. Here there is a equipment and so many parts are connected with and create a GPR equipment. So here first we see that this is the display, um, which is used for to show the subsurface as reflect wave image, and here and fireglass cut film, which is the um, used for moving the GPR machine equipment, and here a cell battery which produce the uh, electric to generate the electromagnetic wave, and also run the display. And here GPR sensor, which is create one which is create the wave, transmitted wave to subsurface for through the transmitter, and also attached with receiver, which is collect wave energy from reflect of object, and they are all connected through the with the display, because display will operate at all the parts, and this part will move the GPR machine. So next, um, we'll see how the working the system of the ground penetrating radar. So here we'll see that the when GPR machine and moving, and at first transmitter will create the wave, electromagnetic wave, and then here one uh, then here one uh, we'll see here, and the wave is reflect it from the object or any layer, and this type, and also here reflect electromagnetic wave, energy will receive through the receiver or antenna in this equipment. And so here GPR test it is used for to investigate the subsurface layer or utility, like say pipe or soil, any rock, or investigate the pavement, or ice, concrete, any conduit, or any metal under the subsurface, any sewage drainage under the subsurface. So here then it is a geophysical method, and also it is a non-destructive method. So if any subsurface investigation required, so we can use this GPR method, or the very cost effective or time effective. So next we will see the how detect any object, and about the GPR. So a GPR range of radio wave can create from 10 hertz megahertz, 10 megahertz to 2.6 gigahertz electromagnetic wave frequency. So here are also GPR electromagnetic radiation in microwave band frequency of the radio spectrum, and the transmitter produce electromagnetic energy. Here the transmitter produce electromagnetic energy, and this energy like a wave, and wave can reflect to any object or any utility or any particle, other particle, and then the reflect wave will receive through antenna. Um, so we'll see that how the reflector and receiving the uh, mm, receiver cycles wave frequencies is. So here if you want to investigate the shallow depth, so we will use the uh, if, 500 megahertz frequencies GPR or greater than, on also generally used 1 to 2 gigahertz frequencies GPR, but we need to more greater depth of the ground investigation, and so we used 50 megahertz GPR frequency GPR, or 100 megahertz frequencies GPR. So as per required depth of the investigation, so we will decide which frequencies GPR we have to use. So, and but low more frequencies will give the better resolutions of the subsurface, and less frequencies will give less contrast or resolution of the subsurface image. That's it will be missed there the many particles which will small than its wave cycle. So it cannot detect by GPR. Uh, so here we will see the how the GPR determine the depth. Here, when transmitter creates a wave and it's reflect from any layer, so here incident wave created, and here reflect here. So here reflect from this point, and also refracted can be happen, but here reflect it will be cross one of the path and one of the length, and but we have to measure the depth of the subsurface or layer. So this can be the time can be detected through the receiver, and how many and distance it is traveling in transmitter and receiver distance is also calculated. So and then we can determine the depth of the layer. So here the receiver antenna they show the result as a velocity of the wave. So each the wave energy captured as a speed or velocity of the wave, and it will connect it. It will calculate it. It take time in the reflected time and incident time, and then it wave velocity calculated on the material of the subsurface. Here we can see that, look at this, we can see that air have velocity 300 meter per microsecond. The wave velocity in air like a velocity of the light. So here wave velocity also water at 33 meter nano microsecond per microsecond meter per microsecond. So different type of material, there is sand, clay, or any rock, it is in into the underground or into the subsurface, also can detect through the transmitter transmitted wave reflect from this material to the receiver antennas. Here concrete, asphalt mix, porosity or steel ill place, still position, and we can detect through this GPR method. So I will see here the wave velocity. Wave velocity how different for different material into the subsurface. So here we will see that how create a transmitter when transmit the wave energy and reflect or reflect in a subsurface layer or any form any object. So it's depend on the material how many wave energy reflect or how many wave energy refract. It is depend on the object or any material dielectric permittivity. Different dielectric permittivity can create the reflection. Upper material have dielectric permittivity is different from the lower dielectric permittivity. So that's why the wave energy reflect or refract here, and then it will receive through antenna. So reflection depends on the material dielectric permittivity. Here reflective percent in formula we can use this the reflected boundary we can determine it through into the display of the GPR as a make contrast or as a make interpret. So as if have any similar dialect permittivity, so it will give the same type of image. So like that here we can see here if you see look at this, if we see here this here, if we see this person give same type of image. So here this material this material have same dielectric permittivity. Okay, understand? So say these material have same dielectric permittivity. Also, the actual permittivity of the different material, we can see that here, if so, it gives the more the black or large contrast resolution. If we have low dielectric permittivity, so it will give the least or low resolution of the like a white band. The errors reflexive strength in percentage depends on the permittivity, we know. So if has a more direct permittivity, it will give the better reflection of the wave energy to receiver. So have greater reflection and strength percentage than any weight non-metallic pipe or drainage system, or and it is also greater than the gas or dry non-metallic. So we can see the this order which has more reflexive strength. So this wave energy reflection and depends on subsurface dielectric permittivity property. We'll discuss that. Here we'll see first. If in wave energy through the object and it's reflect the object from reflect wave energy from object can be observed by the subsurface material. So it's happen when the electric conductivity is more of the subsurface material. So it will absorb the wave energy. See here, look at this. Here, the wave is going up to this depth from the object, but it cannot reach to the receiver. So here, this type of material have more high electric conductivity, which can absorb the reflect energy. So this object cannot detect through the receiver. It is invisible. So we have to alert about this type of material. Uh, After GPR test, and the data will collect from GPR machine equipment and through the memory card, and it will put into the analyze software. So after analyzing, we can get this type of image. In the image, they will analyze the depth of the data, depth of the object or any layer, and position of the object. This image create the wave positive or negative energy. So here positive give the black line, or negative energy give the white line, and also this interpreting data calculated from velocity of the wave and travel time, and then determine the depth or position. And we can see the black portion, the positive and negative of the here, also positive and negative. And we know the different dielectric permittivity have different reflection strength. So here this is the different material, and like a massive ice, or this is the different material of the boulder gravel. So here reflect the wave energy, and detect the there are different layer through black and white band, and by GPS. If any object or utility defined by indicate by this type of curve or any hyperbola, there are so many hyperbola here. If they are largest contrast, so a large reflection and is created. They are have a lowest contrast, so it is the low reflection. There here the this give the large contrast, indicate large reflection from different layer. But here is the subtle constant, indicate the low reflection. Here may be something low dielectric permittivity or high electric conductivity material. So if is any it give the strong hyperbola. Here we can see is strong hyperbola, or here we the is strong hyperbola, which give the which can be a rock, clam, any that is a debris material, uh, or any underground structure conduit. So if give the weaker hyperbola, that's like there's there here, yeah, here. If any weaker hyperbola, so if a weaker hyperbola, so here maybe water line. Also we can see here into the shallow foundation, weaker hyperbola, maybe this type or hyperbola. So it's maybe the water line. Uh, hyperbola cannot give us properly. Image cannot see properly or cannot detect properly. So it's called as a weaker hyperbola. So it's a wet water line, non-metallic gas line in dry soil. More contest in shallow depth. And less contest of the layer. This portion the least contest. It may be happen greater depth of the subsurface. So if depth is increased, is depth is increased, the particle reflection and will be less received by antenna. And also we'll see water line, how can measure the water table? Water table, how can be reflect? This is the water table line. Here, upper portion, the white and black and band indicating, and this is the dry material. Dry material have a different, have more constant, more interest, and had in the water line. This the breaking the curve. If they are having one type of material, one type of layer, but this line breaking this layer. So water table line or this line in show the up to saturation line of the layer. So we can detect through the GPR flow line in under the ground. So and then we will see the utility curve or hyperbola create from the object. Here, if one object mm, in the subsurface or under the ground, so if our GPR are moving from one place to another place as a line, so this transmitter wave energy like as a cone energy. Hmm. When it is far from object and its angle of the cone is greater than 90 degrees, and its hyperbola will is a will wider or just this type of hair wider. If the angle of the cone it is less than 90 degrees, so it's utility curve. That's utility curve will as a V, just here we can see there has a V type of or narrow type of hyperbola. So here we can detect the object under the ground and through the hyperbola, how it is far from the surface or near about the surface. Mm, and also can detect the GPR ground surface to the of main line. Just say if this is gone, the transmitter through like this. So if through this direction, if this direction. So here the utility gave the more wider utility curve. Okay. utility hyperbola. So here is have gone and this direction, and any object is present here. So the hyperbola curve like V cut, and also if the distance from the ground surface is closer, so it give the hyperbola give the flatter type. Also this hyperbola tail indicate the utility distance, and same hyperbola if have the same hyperbola, so here also, um, and then again here also, and then again here also, the same hyperbola can be has same depth, or the same object, the same pipeline, or same conduit in, into the subsurface. Again, then we will discuss this the here, if there are any drainage or strange or any foundation wall, so reflection will be happen this type, and also closer ground will be happened perpendicular, and so if is the more depth from surface, uh, so it will give the different type of utilities hyperbola, or if any hyperbola give more than and three, more than two, so it may be happen that the wave energy reflect under into the pipe, or into the object, that type. If air object reflect this type of reflect, double reflect, and then out the out from the object and receive the receiver. So we'll see the first A type of if more depth object, so we'll see this type of hyperbola tails here. These have more depth object here, have give low contrast resolution. This is give low contrast resolution, and this is give high contrast resolution. So it is in shallow depth, it is in deeper depth, and we will see them. And first A object, it is a for any round type of or nine type of object, so it is like a hyperbola tail, uh, and this image here are more than two hyperbola tails. So here three hyperbola means, we also discussed that three hyperbola means the wave energy reflected more than and two times into the object this type. It will give the more than two hyperbola. Uh, so first hyperbola is for the top of the object, and second hyperbola is the bottom of the object, and third hyperbola maybe bottom of the object, and is the reflect more than two, reflection more than two. So and if any object an oil wall, or vertical wall, or any drainage, so it give this type of, so this image indicate that at this X type, so it may be trench or drainage and wall, wave energy reflect from the object into the ground, and GPR detect and this type of image, this type of image. It is maybe any particle, any rock or any debris or metal or concrete structure or so if any debris of the steel or from the after construction in the subsurface or shallow depth of the subsurface. So it will give the ringy response. It will have to consider to this type of material present here. So all image I'm giving the data or giving I am saying it is happened and after the exploring or digging the subsurface. So that after the calibration and of the image, so the producer of the researcher or decide that this type image gives indicate it the or different type of material or particle of the ground surface ground. So here we will see the if the any water line or if any ice surface is on the ground just have conducted, so the interpreting data give this type of image. So here there are some black and white and frequently here. So this ringy type of response frequently change as per depth. And also here this is indicating the water table, groundwater table. So how we can detect the water line or water table through this GPR method. Yeah. If there are more hazy type of interpreting data or image from through the GPR, so we have to background filter we have used this image. If there are so less contrast or there are more contrast, so we can eliminate if we used one GPR, thus if we used the one gigahertz frequencies GPR, so we can detect this type of image and I apply the background filter, so we can see this type of image of the same data or same ground surface. But if we want to more contrast, so as per discussed also, we will use the less frequencies GPR data here. So here the we'll see the how ground or GPR data is disturbed by another noise. Here you transmit the wave energy and receiver receiving, but now we will see the how the noise or any other wave disturb the ground waves. here ground waves, but direct wave can happen, and or direct air wave also can be happen, can be detected by a receiver. So in same time, or difference time, but direct wave receiver can receive the direct wave or ground wave, but it cannot not, distinguish, or it cannot uh, detect the different, which is direct wave, which is ground wave through the receiver. So it is the drawback of the GPR method, but it will give more black and white type of uh, disturb noise at top of the first layer here. It will give this type of black and white band straight line. So if the direct wave here, if the direct wave is the less than and 0.033 meter per nanosecond, and so we can and consider the this is the in air or in subsurface, or it is a direct wave from transmitter to receiver. So depth and velocity. Velocity, we'll see. If any other noise or air wave detect through the receiver, so it will give the this type of band, white, black and white band on line only, or if the, any other noise from radio frequency of the military station, TV station, any other network station. So GPR cannot can record it, or also GPR wave can bar it from this type of noise radio frequency. So here, up to this depth, the GPR frequency and noise frequency is same. That's why this up to this depth, the image give blur type. Image give the data which has in the um, ground surface. But after death, the noise frequency is more than the after that the noise frequency more than the this GPR receiver wave energy data, frequency data. Uh, so it cannot give the cannot be give the better image, or it will be disturb the interpreting data. So this is the drawback of the GPR method. So we have to alert if any frequencies, any other frequencies is have coming from any other station, and so we also be determine it. And then here velocity, if the less than and 0.03 meter, so if any here from, so we can and known as is in the air, if it is the velocity, if the velocity is 0.03 meter, so we can consider the object in air or surface. And another, if we'll see that the ion transmitter or GPR is grow through into the building or in any shade. So here, so going and it will give this type of image uh, of the ground investigation during ground investigation. So we have to consider this image as is showing the this building here. The air give this white type of band, and this give this black band, and this give this black band. So we have we cannot say there is any pipeline, any rock in the into the ground. So we have to alert in this time. We have to also notice the when the GPR is going through the any building or any set. So this image, as we can also determine it through the length. Also, we can, if we want to survey this building through the GPR, so here we can determine the depth of the slab to bottom, top to bottom, and here this is the depth of the top layer and bottom layer, and this is the give the uh, uh, depth of the top layer. So we can determine the height of the slab, top slab, here, and also can determine the length of the object. And if the GPR going through the beside the any building or any lamp post, so reflect energy, reflect wave can record it through the GPR. Through the GPR here, reflect wave can receive through the GPR. So this time we have to remind that if the velocity is 0.033 meter per second in the after interpreting data, we have to decide it is in the air. So here what happened? The transmitter transmit the wave energy, and when it reflect from object or ground, and it is leaked into the air. After leaked, it is reflect from the lamp post or any wall of the building, and so it can determine or it can record it, or it can receive the wave energy by receiver or receive antenna. So in this time, we remind the velocity of the wave, and it will give this type of image. So a ringy response. So we have to we have to gain more knowledge as through the testing and through the GPR producer or GPR distributor and have to gain the knowledge how used the GPR and what image will give the more indicate at the what object. Okay, thank you.
what I do is I look for the storm and cyclone records in the subsurface condition. So whenever any cyclone occurs, you could get some deposits which could be very different than normal beach deposits, or you could get very big erosional scar, because cyclones are like high energy waves. They erode the coast and they take everything back to the sea, and then that you see in the GPR. So this is everything what we call a GPR. This is called DVL. This is called transmitter and receiver, because there are two boxes you can see, right? So one of those is transmitter, other one is receiver. Same goes with this one. These two are different frequency. So that's 250 megahertz. This is 500 megahertz. Can any one of you tell me, like, why do we use different frequency?
There will be different types of soil, so for penetrating in that, depth.
So what do you think, like, by which frequency we can get greater depth, like 250 or 500?
250.
250 greater depth. But the resolution won't be as good as 500, because if you increase the frequency, depth of penetration decreases but the resolution increases. So you have to like run all the system and see what works best for you, because like for us 250 megahertz is working fine. That's why we are using 250 megahertz here. Okay, so now we'll start the setup. This is called smart card, which you can see here. That's the battery, and there's one odometer which you see in like motorbike and in car everywhere, right? So whatever amount you move on like land, you can see on the digital video logger. Like you moved 5 meter, you moved 10 meter, 15 meter. So you'll see when we'll take the GPR data. And if you have any question in between, just feel free to. Different composition. So there could be treasure, there could be just a small root. So you don't know just by running GPR what's inside. But if you get something of your interest, you can dig down there and see what's exactly down there. So GPR would never tell you what's inside. Okay, now we'll set up the 250 megahertz.
Yeah, the transmitter cable. Yeah, I think there's another place where you can put the odometer, but it's safe to go there. It is set here, so now we'll just plug in the battery. The battery is here, and this is the cable that goes with the battery. Okay, do you want to record here now because
I'll just press anything and then this instrument will turn on. Come. Let's go that side so that more people can see. Okay. Take few seconds. Okay, the instrument name is Sense. Okay, do you mind if I go there? First is run pulse echo GPR, second is system setup, third is view setup, fourth is file management, and fifth is shutdown. So right now we have to set up the things because things are already set up, but since you guys are learning now, so I have to show everything to you. So if you go to the system setup, you'll see GPR parameter, acquisition control, survey parameters, display parameters. There are so many things that you can go through, but the main thing that you have to deal with is number 1 and 2, which is GPR parameter and acquisition control. So in order to go to that menu, you have to press, like if you want to go to 1, you have to press 1. If you want to go to 2, you have to press 2. So let's go and see what's GPR parameter. So right now, since we were already using this, it's showing 250 megahertz. But if you would change it to 500 megahertz, you have to change it. So for example, you have to change it to 500. Then as you would go down, you'll ask like set to suggested value, because since manufacturer build this, they already know like what's the parameter that would fit best to run particular frequency. So if you would press A, everything would be set up in accordance with 500 megahertz now. But we are using 250, so we would change it back to 250. So let's change, press A. Now it's back to 250. Press 1, and then you'll ask. And then, yeah, so now everything is back to 250 megahertz. So that's already set for us. There are different things you can look at. You can look at time window, because when you run GPR, you would never see depth. GPR will always tell you in time section. You have to use the software, do the velocity calibration to get the time to depth like axis. So you have to convert time axis to depth axis based on like velocity calibration. So you will always see the time when you look at the GPR image. So that's time window, like how much time you're seeing. You could increase it. So go down. If you increase it, you can see like depth will also increase. So if you go to 110 nanoseconds, it's 4.95. If you are going to 120 nanosecond, it's 5.4 meter. So there are some depth velocity which is already set. In this case, this is radar velocity, which is 0.1 meter per nanosecond. But this could not be actual velocity, because GPR uses radio frequency, and radio frequency's velocity changes based on like what's there in the subsurface condition. So here it could be like 0.12 meter per nanosecond, somewhere it could be 0.08 meter per nanosecond. So you have to look at the GPR in software, and then you have to do the velocity calibration to get the exact velocity. But just for sake of convenience, we have just taken here 0.1 meter per nanosecond. So that's everything. Let's change it back to 100, which was already suggested value. So for suggested value, you would see there's one star here, right? If you would change anything from suggested value, the star will disappear. If you'd go back to the suggested value, the star would come back. So that's the suggested value for a particular frequency. This is antenna step size. So step size means after how much distance transmitter will trigger the pulse, because transmitter doesn't trigger pulse all the time. It only triggers after a particular distance, which is known as antenna step size. So in this case, antenna like transmitter would trigger a radio pulse at 0.05 meter, which is equivalent to 5 centimeter. Then radar velocity, which you can set, but it's better to like set this radar velocity based on the software recommendation, because you can take out the data. There is one, sorry. So there's a removable disk. You can take it out, get the GPR data, and then you can process it in your laptop, but you need the software license for that. Okay, system stacking is something, uh, can anyone tell me what system stacking? What is stacking, if you guys know? So it is like at each point how many times GPR would stack the same data, because you know once you stack the same data, the error decreases, right? Because the average would seep to the mean. So higher the stacking, higher resolution data or more accurate data we will have. Lower the stacking, the data won't be that good if you would look it in the like on the screen in laptop or in software. So the suggested stacking is 8 or 16, that works fine. Okay, that's all for the GPR parameter. Now second is acquisition control. So you can see the trigger method is odometer. So we know the step size is 0.05 meter in this case. So every time the odometer will move 0.05 meter, the transmitter would trigger a pulse. So the trigger method would be odometer, because odometer is moving, and once 0.05 meter point is reached, the transmitter will trigger a pulse, then again 0.05 meter, then again transmitter would trigger the pulse. So that's the thing. There are more things here, GPS, which we have not connected here. I think IIT Bhubaneswar doesn't have GPS for Pulse Echo Pro. So in that case, you have to take the topography data, because GPR would just tell you the time axis. But if you want to convert the time axis to depth axis, you have to get topography data, like how the land is changing in elevation, because GPR would show everything in flat based on the time axis. But if you want to convert time axis to depth axis, you have to take the elevation data. So in our case, we use dumpy level. I'm not sure if you guys know, that's like leveling instrument. So yeah, so dumpy level, but it's good to have GPS attached with GPR. So GPS parameter we won't look through because there's no GPS here. Let's go back, and then let's go back again. Run Pulse Echo GPR. There are many options. You can see like collect line data, collect grid data. So grid data means if you want to look at the data in 3D, you can take a grid data. So like just go 10 meter, 10 meter, 10 meter, 10 meter, 10 meter, 10 meter. So once you form the grid, and there are software which can transform that grid data into 3D data. So then you can look at the GPR data in 3D. Okay, now let's run the Pulse Echo GPR, collect line data because we are moving towards a line direction. And then it will show you like what's the directory number. So this is select line number. We've already taken point like line 00, line 01, line 02, line 03. So that's why you can see a star. So these files are still available to take data. So you can take data in 04, 05. So we'll just press 1, which is for run. And now you're good to get the data. So let's just rotate it. Okay. Okay, now you have to press start. Okay, and now once you'll start moving, you can see data coming up here. So let's just move a bit. So you can see there are different layers down there, which you can see as laminations. If you know the geoscience term, we call it lamination. So if you would dig down here, you'll see like these layers, how it's changing. There are some unique features which you can see here. There is a particular shape here, which you can see. What do you call it? This particular shape. I mean, you guys are engineering students, so you should know. Point object down there. So when you cross the GPR over that point, you get the hyperbola. Does anyone have notebook here? You guys think you can use GPR for?
First we have to select some location wherever we want.
Yeah, but like what do you want to look in the subsurface?
For constructing a road or something, we can get to know what is under the road.
Yeah,
like
we
for
have to
pipe.
identify utilities, because if there are utilities and you just stick down there, you might just like rupture things.
Yes.
So you have to confirm what's inside there so that the construction won't be affected due to something which is in the subsurface condition. People use this for also reinforcement. So like how the concrete, like how the reinforcement is stacked in the subsurface. So for that we use like very high frequency 1000 megahertz, because in that case you need like very high resolution and less penetration depth. So for reinforcement you just use the higher frequency. Archaeology people also use a GPR. Military people also use a GPR to like identify underground mines if there are something down there. That's for military people. I mean, GPR has very diverse range of application. So based on what you want to do, you have to select particular frequency. Surface, we are running the GPR on. This is our GPR, something like this. Okay, let's say this is the GPR. There is some point object down here, like this is the point object. Now transmitter trigger down the pulse. So let's say at this point when the GPR was at location 0, this is location, let's say A, B, C. So when transmitter would trigger a pulse, it'll go in all direction, but since there are some utilities here, it'll go through this and then come back to this. But GPR never knows in which direction the signal is coming from. It just measures the time the signal went and came back. So GPR would tell you like, okay, this signal is coming from, so this, let's say this is D. So this signal is coming from some depth D. Okay. Now the GPR will move here. Okay. So the frequency will go here and then come back here. Now this distance, which is D2, it's smaller than D1, right? So this point you would see like, okay, this is coming from this point. Okay. Similarly, it would go here, here, here as GPR is moving towards this direction, and then as it's going away from here, it'll just come back like this. So the structure we would get is a hyperbola, and that's what you see here. So that's why you see hyperbola when the point object is there in the subsurface condition. If you would go on a planar surface, like let's see, this is the subsurface, this is the surface, this is some layer in there. So in this case, if GPR would go, it'll just trigger down and then come back, right? So you would see the same surface. There won't be any difference because the subsurface structure is at the same depth at all points. So you'll see like as it is. So these laminations that you see, these are the actual laminations. These hyperbola you see, these are the point object in there. So that's why you see hyperbola. Okay. Yeah, so these are hyperbola. You can see this one, this one, this one. And this could be because of the tree roots. This could be because of like some metallic thing in there. Could be some utilities. But in this case here, there won't be any utilities. But these hyperbola could be anything that's like pointy. It could be a pipe also. If the pipe is going perpendicular to the GPR transect, then you would cross it, but it'll be just a point crossing, right? So you would see a pipe as a hyperbola when it's crossing perpendicular, right? So if there's any pipe going down here, you would see like a hyperbola if you're crossing perpendicular to it. Now there's another thing that people are interested in, water table. Yeah, Gaussian is interested in water table. Right now here we cannot see water table, but if we would go somewhere down there, then we might be seeing water table somewhere. Okay, let's go there, then we'll see. Okay. So anyone wants to drive it? Just slow down. Yeah. Can do it like one by one. I mean, I don't. 4 meters. So you have moved like 250 meters from the way from the point we started. And the last thing is, yeah, GPS info which is not available. Yeah. We'll take another line to see water table, but for now, just to save it, you have to press 8, which is pause, then exit. Now you know. We'll do it again to see water table. So now you see like your line 04 has star beside it, so it's saved. So you have your line in the removable disk here. Okay, now let's take another data which is 05. Press 1 to run. Okay, let's just make some changes because right now we saw here, if you look at the data view, start. So this is the data we just took. So you can see there are some data going down there, right? So we are losing some data which is at some depth. So we can increase time window to recover all those data. So let's pause, exit, return, system setup, GPR parameter. Now we'll increase the time window. Go here, increase the time window. Let's keep it 150 nanosecond. So these suggested values are not always ideal. It's just like based on the majority of data that has been taken so far, but this is not always ideal. So once you run your GPR, you can change this value based on like what you require. So let's go back now, return, run, collect line data. Now it's line 05. Okay, now who wants to run it? We'll go like 50 meters. So you have to press start and then start moving it.
Second.
But then again continuing, right? This particular lamination, it's continuing across.
Okay.
So this is the water table. Water table is because it's air then water. So there's a huge dielectric property contrast. So that's why you get the water table in such a way. But these lamination are continuing all across water table because this is not a layer, it's just water table. So that's why all laminations that you would see are continuing across that particular line. Let me see if I have, so I'll open the data which we collected yesterday. There I think you can see it more clear. So the data was on the same track. Okay, we collected line 0. Let's run it, view. Right now I've opened the data which we collected yesterday because right this particular section the water table is not as clear.
नहीं जंगल खत्म करते हैं जंगल को खत्म करना है
It'll come, like just give it some time.
अभी क्लियर नहीं हुआ
This is 6 to 7 meters of depth.
This first one is noise.
That's the direct wave because transmitter is sending down the pulse, but some of the frequency directly coming from transmitter to receiver. So it's not going in the ground, just coming from transmitter to receiver. That's why you're getting very, very strong reflectance. Yeah, that's why it's just flat.
ఏం లేదు అన్ని అవే గీతలు ఉన్నాయి వచ్చినప్పుడు చెప్తుంది
If I can speed it up. This, that's the fiducial. So if you're running a GPR line and then you see like, okay, at this point I'm seeing very unique. So just to mark it on the ground, you can press fiducial and then that will be on your GPR data. Like it'll be attached to your GPR data. So when you open it in like software, you can see, okay, at this location I saw something unique. So we call it fiducial.
What is that F6?
That's fiducial. F6, F7, F8. So in this case, we mark fiducial at every 10 meter. So can anyone see where the water table is in this case? Yes, that's the water table. Okay, let's pause it. Why do you say this is water table?
Lines are more close.
It's looking like continuous.
Yeah, so like all the lamination that you see up that line are continuing across. So if it would be some layer, then if you have some layer coming across, it'll truncate. You won't go through that. But in this case, you can see everything is coming across that. So that's why it's water table. Let's keep it going. You can see it more clear.
वाटर टेबल है इसलिए पार करके चला जा रहा है ये करके अगर उसको क्रॉस करके चला जा रहा है लाइन को क्रॉस करके निकल रहा है ना वाटर टेबल है इसलिए इसको क्रॉस करके निकल जा रहा है
Or processing step or something. I mean, right now you see everything flat on the top, right? But once you put in the topography data, you can see the surface elevation. Let me see if I have some data with topography. Hopefully this one will have some. Not this one. Okay. So once you key in the topography, you would see like data somehow like this. So you need to have the topography data since you don't have GPS. Once you have GPS, you can see data directly in the topography. But if not, then you have to collect topography with dumpy label, then attach that data to the GPR data.
How you attach that data?
It's just the software. I think software will allow you to do that. So go to the software. You need the license key for software. It's $3,500.
जहाँ से खरीदते हैं ना मशीन वो लोग तक लेके जाते हैं
It's taking some time to. Okay, add line. Just add some line.
In GPR machine have not any option the what is the elevation level?
No, because GPR always see the two-way travel time. It never says how if you are going down, if you're going up. So you need to have GPS attached to GPR. So if you go here, attachment, you can just add a file, which will be .top, which will be for topography. And then once you attach it, you can see the topography. Yeah. Okay.
We are getting the distance also, but it is wrong, right?
What?
The distance.
The distance?
Elevation is not showing.
Distance is also